Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I am Azmat Ali and I welcome you all in class of O-level mathematics. Our discussion is continue on linear inequalities in two variables. In this topic, today we will discuss some problems that are related to writing linear inequalities of two variables from graph. In today's lecture, we will discuss some problems in which graph of some inequalities are given and we need to find the corresponding inequalities. Here, the book that I am using here is a new Syllabus Mathematics series by Dr. Yeap Ban Har. And from this book, from chapter number 1, we will discuss here exercise 1A, and from this exercise we will discuss question number 2, that is of intermediate level, and as well as question number 3, that is of advanced level. So before going to start our class properly, here there are some key points that we will use during our lecture. Suppose we have a equation of the form x is equal to 8. This is a vertical line, and the second one is y is equal to b, and this is a linear equation in two variable y is equal to mx plus c. If unshaded region is on the right side of x is equal to a, then inequality is x greater than or equal to a. Suppose we have equation of the line x is equal to 5 and the unshaded region is on the right of x is equal to 5. Suppose this is x is equal to 5 here, and the unshaded region is here. Here is unshaded region. Then for this unshaded region, the corresponding or associated inequality is actually x greater than equal to 5. Mean to say, for the inequality x equal to a, if the unshaded region is on the right side, for the right side we will use inequality x greater than equal to a, while for the left side we will use inequality x less than or equal to a. Similarly, if we have equation y is equal to b, that is actually horizontal line. If the unshaded region lies above this line, then inequality will be y greater than or equal to b. And if the unshaded region is below y is equal to b, then inequality is y less than or equal to b. And if our line consists on two variables y and x, and the unshaded region lies above, then for above again we will use greater than or equal to sign, and for below we will use less than or equal sign. From these key points, you can observe when unshaded region is on right, for right side we will use greater than or equal sign. For left side we will use less than or equal sign. And for if unshaded region lies above, then again we will use greater than or equal sign. And if unshaded region lies below the line, then again we will use less than or equal sign here. Further, if our line is dotted, in case of dotted line, we will not use equal sign. Mean to say, suppose our line is y if from the graph of line is like this is dotted line, and the unshaded region is here below the line. This is unshaded region below the line, and suppose the equation of this dotted line is y is equal to 3x plus 5. Then for this dotted line, the associated inequality will be y less than 3x plus 5. So these are the key points that we will use during our lecture. So let us discuss properly question number 2. This is the graph of okay. In question, in each of the following cases, write down the inequality which define the unshaded region. We need to find the inequality for this unshaded region. Here, unshaded region is this white area. The white area is unshaded region here. This is unshaded region. Here there are total 4 lines here, sorry. First line is y is equal to 3. As this line is a solid line, this line represents y is equal to 3. Now, as the unshaded region or the white area is below here, this is our y is equal to 3 line and the unshaded region is below here. So, the inequality, associated inequality to this line is y less than or equal to 3. Similarly, the second line is y is equal to 0. That is actually x-axis. As the white area lies above this, so the associated inequality is y greater than or equal to 0. The third one is x is equal to 0 and the unshaded region is on the right side here. This is unshaded region. So, the associated inequality in this case is x greater than or equal to 0 here. The last one, this inequality, x plus y is equal to 4. For this question, the unshaded region is below this line. So, the associated inequality is x plus y less than or equal to 4. So, we will write here the unshaded region, the unshaded region is defined by the four inequalities First is x greater than or equal to 0. The second one, y greater than or equal to 0. The third one, y less than or equal to 3. And the last one is x plus y less than or equal to 4. So this is a procedure to write the associated inequality when graph of linear inequalities is given. Next we move towards second B, C and D part of second question. So this is the B part. Here the unshaded region is this white area. This is the unshaded region here. So let us consider first here this line 3y plus x plus 9. For you can write it as for 3y is equal to x plus 9, unshaded region is below 3y is equal to x plus 9. The unshaded region is below 3y plus x is equal to 9. So 3y less than or equal to x plus 9 defines a part of unshaded region. Similarly, for other lines, you can write for 3x plus 2y is equal to 6. This is opposite to, this equation is opposite to this inequality. Now, this is the line that is actually represent 3x plus 2y is equal to 6. As the unshaded region is below this line, we cannot use the term here left on the right side, because here the words terms right and left only used for the vertical line that consists only in one variable x. As this equation consists on two variables x and y, so in this case we will use the terms below and above. So as unshaded region is above this line, so the associated inequality to this is 3x 2y greater than or equal to 6. The last one, x is equal to 3. This is a vertical line that consists only on one variables, and the unshaded region on the left side of this. So the associated inequality for this is x less than or equal to 3 here. The last one, 2y is equal to x. This is a dotted line. This is a dotted line. As the graph of this inequality, as the unshaded region is above this line, so the associated inequality is 2y less than x. We will not use here less than or equal sign, because at this time the line is dotted. This is not a solid line here. Hence, the four inequalities that defines the unshaded regions are: the first one is 3y less than or equal to x plus 9. The second one is 3x plus 2y greater than or equal to 6. The third one is x less than or equal to 3, and the fourth one is 2y less than x. So this system of linear inequality form the unshaded region. Next one, this is a D part. Okay. Now this is unshaded region. This is our unshaded region. This is unshaded region at this time. Our unshaded region lies this in this area. That is actually white area. This is our unshaded region. So again, this line, for this line, the line is dotted. This straight line is dotted as dotted line. This is not a solid line. Now the unshaded region is above this line, so the corresponding or associated inequality is 2y greater than x. So this is our first inequality. For this line, as unshaded region lies below this line, so associated inequality is y less than or equal, because at this time this line is solid line. This is a solid line here. So inequality is y less than or equal to 2x plus 2. The last one, this inequality. This equation 2x plus y For this equation, unshaded region is below this line. So the associated inequality is 2x plus y less than or equal to 4. Yes. So in this case, the total three linear inequalities that defines unshaded regions are: the first one is 2y greater than x. The second one is 2x plus y less than or equal to 4. The third one is y less than or equal to 2x plus 2. Next we move towards third question, that is actually of advanced level. In this question, firstly we need to find equation of each line. In question number 2, you can notice that equation of each line is given. Like as you can notice that y is equal to 2x plus 2, this is the equation of this line, 2x plus y, this is the equation of this line. So in question number 2, equation of each line is given. Now in this question, firstly we will find equation of each line, and then we will find the system of linear inequality that describe the unshaded region. So in each of the following cases, write down inequalities which defines the unshaded region. We need to find inequalities in each case that defines the unshaded region. So firstly we will find here equation of each line, equation of each line in the graph. The first one, this line, this is a horizontal line here. This is a horizontal line. You know, horizontal line is always of the form y is equal to some real number. Y is equal to a, y is equal to b. As this line passes through y is equal to 4, so the equation of this line is y is equal to 4. Now, as the unshaded region is below this line, so the associated or corresponding inequality to this is y less than or equal to 4. Because this line is a solid line, so we will use here less than or equal sign both. So you will write for y is equal to 4, the graph of unshaded region is below. So associated inequality that defines a part of unshaded region is y less than or equal to 4. Similarly, for other inequalities, you can write all of these lines. For example, the next one, this inequality, as this is neither a horizontal and nor a vertical line. This is an inclined line or oblique line. This is an inclined or oblique line. Oblique line. Always remember that the oblique or inclined line is always of the form y is equal to mx plus c. That consists on both variables x and y. So I will share here the very easy method to write the equation of this inequality. You can notice that this line has y-intercept 5, mean to say a point where line cut y-axis. So this is y is equal to 5, where the line cut y-axis. Similarly, this line cut again x-axis at x is equal to 5. So here x-intercept is equal to 5, and y-intercept also is equal to 5 here. So to write the equation of this line, we can use two intercept form of line. You know what is the two intercept form of line? What is the two intercept form of line? Two intercept form of line is x over a plus y over b is equal to 1. The number in the denominator of x is called x-intercept. So a is x-intercept and b is y-intercept. This implies the required equation is x over 5, because x-intercept and y-intercept both are here 5. Y over 5 is equal to 1. Multiply by the LCM, we have x plus y is equal to 5. So this is the equation of this line. This line has equation x plus y equal to 5. Now, the unshaded region is below this line. So the associated inequality is x plus y less than or equal to 5. The last one, this inequality, this equation, this line passes through 2 points. One is 2, 1 and the second one is origin. Very interesting. Remember, when a line always passes through origin, that line have a no y-intercept, non-zero intercept. Mean to say this line is always of the form just y is equal to mx. Here y-intercept will be 0 here. So to find the equation of this line, we will use slope point form. Firstly, we find gradient or slope. You know, formula is y2 minus y1 over x2 minus x1. What is y2? You can suppose this point 2, 1 as this is x2, this is y2, and for the second point is origin, from where the line is passed. This line passes through 2 points. Firstly origin and then from this point. So there are the 2 points from where this line is passing. The second point, the first point is origin 0, 0. As you know, the coordinates of origin are 0, 0. So suppose this is x1 and this is y1. So by substituting these values in the gradient formula, we have y2, this is 1, y1 is 0, and what is x2? X2 is 2 and x1 is 0 here. So this is the slope of this line. So lastly, by putting all values in the formula, slope point form. You know, slope point form of line is slope point form of line. What is the slope point form of line? Y minus y1 is equal to m into x minus x1. What is y1? y1 is 0, slope is 1 by 2, x minus 0. So the required line is y is equal to x by 2. So the equation for this line is y is equal to x plus 2. As the unshaded region is above this line, so the associated inequality is y greater than or equal to x by 2. Hence, finally, the system of inequalities that describe here, that define here unshaded regions consist on four inequalities. First was horizontal line y less than or equal to 4. The second one is 1. Second one is y greater than or equal to x by 2. The third one is yes, this is x plus y less than or equal to 5. So these three inequalities defines the unshaded region. Last one. Let us discuss one more question here. Next we will discuss here C part of question 3. Firstly, we find the equation of this line. As this line cuts x-axis at 2 and y-axis at -1. So by using the two intercept form, the equation of this line is x by 2 plus y over -1 is equal to 1. As you know, the two intercept form formula is x over a, y over b is equal to 1. Multiply this line by its LCM, we have x minus 2y is equal to 1. Next one, as the unshaded region is above this line, so we have the associated inequality to this x minus 2y greater than or equal to 1 here. Okay, I have made some mistake here. When we multiply this line by its LCM, the right side will be 2 here. Further, here the unshaded region is below this line rather than above. So here there will be less than or equal sign. So the inequality for this line is x minus 2y less than or equal to 1. You can verify whether you have written this inequality correctly or not. Suppose if we take any point of this unshaded region, suppose this is one of the point 0, 0 origin. If you put 0, 0 origin in this inequality, we have 0 minus 2, 0 less than or equal to 1. Left side is 0, 0 less than or equal to 1. This is true. It means you have correctly write the inequality. Suppose if someone write inequality x minus 2y greater than or equal to 1. If we take any point in this unshaded region 1, 1, suppose this is a 1, 1 point that lies in this region. Now, if you put here 1 minus 2 into 1, this will become -1 less than or greater than or equal to 1. This is not true. This is false. It means this inequality does not satisfy the unshaded region. So we will take here less than or equal sign rather than greater than or equal sign. The last one, the second one is this. Now we discuss this inequality. This line passes through 2 points 3 and -1. So again, using two intercept form, we have x intercept is -1, x over -1 plus y over 3 is equal to 1. By multiplying both sides by LCM, we have minus 3x plus y is equal to 3. By multiply 3 on both sides, we have this. Next, as unshaded region is below this line, so the graph is -3. So the associated inequality is minus 3x plus y is less than or equal to 3. You can take again a point from this unshaded region and put in this inequality and can check whether that point satisfies this inequality or not. Suppose again we choose origin and substitute this point in this inequality. This will become 0 less than or equal to 3. This shows 0 satisfied this inequality. The last one, this one. This line passes through two intercept, y-intercept 4 and x-intercept is 3 here. So equation is x over 3 plus y over 4 is equal to 1. Multiply by LCM, that is 12 here. We have 4x plus 3y is equal to 12. Now unshaded region is below this line. So associated inequality is 4x plus 3y less than or equal to 12. Again, you can take any point from this unshaded region and put that point in this inequality and check whether that point is satisfied by this inequality or not. So the three inequalities that define the unshaded regions are: the first one is x minus 2y less than or equal to 1, the second one is minus 3x plus y less than or equal to 3, and the last one is this. So in today's lecture we have completed question 2 and question 3 from this book. Inshallah, in the next lecture we will discuss the remaining questions. I hope today's lecture is helpful for you. So meet you in the next lecture. Take care. Allah Hafiz.